Well, hello everyone. It's a little bit before my son's orchestra concert, so I thought, well, I'll get a lesson in. And we are working on solving 2x2 systems algebraically. And we're going to work on the methods of doing that. And the first method we'll talk about is substitution. Substitution requires that you get one variable by itself if it isn't already. In one equation. Just one equation, not both. And I think I'm going to choose the first equation. I've got x plus 2y equals 8. And it's easy enough just to subtract 2y from both sides and say x is equal to negative 2y plus 8. Now after you have gotten this by itself, I'm going to substitute this 2y minus 8, negative 2y minus 8, for x in the second equation. Well, here's the second equation. 1/2 x minus y equals 18. And I said I'm going to substitute this negative 2y plus 8 in its place. So I'm going to put 1/2, and then we'll put negative 2y plus 8 here, minus y equals 18. Well, 1/2 times negative 2y is negative 1y. 1/2 times 8 is 4. And I have this negative y out here still, so I just distributed the half between these two terms, equals 18. Negative 1y and negative 1y make negative 2y, plus 4 equals 18. I subtract 4, and I look at negative 2y equaling 14, and I divide by negative 2, and divide by negative 2, and I have y is equal to negative 7. And for right now, I think that's good. And now I want to find x. And since I got x by itself here, it might be easy just to plug in x in place, or negative 7 in place of y there to find x. Negative 2 times negative 7 is 14. 14 plus 8 is 22. So my answer is negative 7, 22. Now what I'd like for you to do, if you're so inclined, is to substitute negative 7 in for x, substitute 22 in for y, and see if that works. Alright, but before you do that, I said x is 22 and y is negative 7, and why I was hesitating was I was plugging that in the other wrong way and it was not working for me. But try it this way and see what happens. The next way I want to work on is elimination using addition or subtraction. Your goal is to eliminate either one of the variables. Eliminate a variable. Now, I'm looking at our system right here, and what I see is if I subtract 2b from this 2b, b is gone. So I am going to subtract everything. 4a minus 2a is 2a. 2b minus 2b is 0b. 15 minus 7 is 8. So by subtracting. Now if they were opposites, I would add. But your goal is to eliminate one of the variables, and we eliminate b when we subtract the two equations. Divide by 2. 8 divided by 2 is 4. Okay. Now, let's go into one of the two equations. I'm going to pick the first equation and use 4 in place of 8. 4 times 4 plus 2b equals 15. 4 times 4 is 16. Plus 2b equals 15. Subtract 16. Subtract 16. 2b equals negative 1. Divide by 2. Divide by 2. And I'm getting b equals negative 1/2. Alright, again, check my work. See if a is actually equal to 4 and b equal to negative 1/2 in the original equation. Next example here is where we multiply and then we use elimination. And what that will require is you want to figure out a way so that you can add the two equations together and a variable will be eliminated. I'm going to go after the y's. If I multiply this entire equation by 2, I'm going to have negative 14y. I'm not even looking at what the other stuff is because I'm going after the y's. So I'm going to multiply this equation by 2. If I multiply this one by 7, I'm going to have positive 14y. And my equation will be, but you got to multiply everything, 6x minus 14y equals negative 28. Let me write that 14 a little neater. Seven times 5 is 35x. I'm just distributing over the whole equation. Plus 14y equals 45 times 7. I'll do a little work over here at the side. 35, 28, and 3 is 13. So that's 315. Now, when I add these equations, 6 times 35, not times, plus 35 is 41. Now I'm adding this time because these guys are opposites and they're canceling out when I add. Now 315 plus negative 28, or negative 28 plus 315 is 315 minus 28. 15 minus 8 is 7. 10 minus 2 is 8. 41x equals 287. Divide by 41. Divide by 41. I know 4 times 7 is 28. 4 times 70 is 28. 41 times 7 is 287. So that has a nice answer. X equals 7. As big as the numbers were looking, we thought maybe we'd be in trouble. X is 27. X is 7. Now I'm going to use the fact that X is 7. I'm going to use the second equation to find Y. And I'm going to replace the X with 7. I could use the first equation if I want, but I'm using the second one right now. 5 times 7 plus 2y equals 45. 5 times 7 is 35, plus 2y equals 45, minus 35, minus 35, just solving for y. 2y is 10, divide by 2, y equals 5. Again, let me leave it for you to plug 7 and 5. 7 for x, 5 for y in both equations and see if these two answers come up when you do that in each equation. Okay, one more example. Negative 4x minus y equals 9. I forgot to write the second equation. Negative 4x minus y equals 9. Now let's take a look here. I am inclined to multiply again, and I think I'll go after the x's this time. I'm going to multiply by 2. I'm going to leave this one as it is and have 8x plus 2y equals 17. Multiplied by 2 because now I have negative 8x, which is going to cause me to be able to cancel out the x's. And 2 times negative y is negative 2y. Uh-oh. 2 times 9 is 18. So 8, negative 8 is 0. Those canceled. 2 and negative, ooh, that is 0 as well. We lost x and we lost y. And somehow that's supposed to equal 35. Alright. It can't happen. If you get something that happens this way, you write that there's no solution. This is inconsistent. And it's really, if you look at the graph, you're looking at parallel lines. If I were to graph both of them, you'd be seeing something like that. Alright, well, I hope this finds you well and that you're ready to go to practice these like crazy on Monday. Thank you now, and we will see you later. Bye-bye.